Welcome back, Math 20-2. Today we are doing trigonometry lesson 3, which is cosine law. Now, we learned about sine law and we know SOHCAHTOA from before. And this year we learned sine law. It's not a right angle triangle, so we can't use SOHCAHTOA. We don't have an opposite side and its angle. Right here, 36, the opposite side would be CB. We don't know that. We look at 6, the opposite angle would be this angle B. 3, the opposite angle would be C. We don't know one of those ratios, so we can't do the sine ratio. Well, there is a long way using sine, but there's a better way using our trig ratios. So first we're going to do it the long way using SOHCAHTOA. Well, in order to use SOHCAHTOA, what do we need? We must have a right angle. So I extended this triangle here, extend the triangle to make a right angle. So now we have this right angle triangle here in orange. Okay? Now with that right angle triangle, we know the hypotenuse is 6. Okay? We know angle 36. But we don't know the rest. But because of that, I could find CD, which is my adjacent. Or sorry, my opposite of 36 is CD. So let's try and find what CD is. So if 36 and the opposite is CD, and we know the hypotenuse, we're going to use sine from SOHCAHTOA. Okay? So let's take a look at this. I am going to know that sine 36 is equal to, sine is opposite over hypotenuse, which is in this case CD, line CD, which is my opposite, all over 6. So to solve for this, I have to multiply both sides by 6. I'm going to get 6 sine 36 is equal to CD. Okay? And so then my line CD is equal to, I'm going to get, calculator, 5.3, or 3.5, approximately. Okay? Now, we have this as 3.5. So now let's try and do AD. Let's try and find AD. Alright? So that's going to be cos. 1 second. So when looking at this, AD is my adjacent to 36, so we're going to use cosine. I'll just do that over here. So we're looking at cos 36 is equal to AD, my adjacent over my hypotenuse of 6. Alright? So in other words, multiply both sides by 6. I get 6 cosine of 36 is equal to line AD. And that's going to end up getting me 4.85. Alright? So now I know this is 4.85. From here to here is 4.85, or 4.9. We continue this here, and we look at this. Now, I should be able to find this line here because of this triangle here. Because of this triangle, CDB, we can now find line CB using sine and cosine. So CB is equal to, well, in this case, it is my hypotenuse. Alright? And what do we know? There's two things we know here. I could even use the Pythagorean theorem, because we know this here, this distance here, BD is, or I could use trig ratios, because BD, we have to figure out BD is going to be 4.85 minus 3, because 3 is from there to there, and this whole distance is 4.85, so that's going to be 1.85. So I could either do a sine ratio and find this here, an angle there, or an angle there, or I could use the Pythagorean theorem. I'm going to use the Pythagorean theorem today. So I'm going to have c squared is equal to a squared plus b squared. Well, my hypotenuse is what I'm trying to find out, that's CB, is equal to, my a squared, I'm going to say, is 3.5 squared plus 4.85 squared. Now I calculate that out, I am going to end up getting 15.88 something squared. And then when I round this off, I'm going to end up getting, we have to, or 15.88, and it goes on 3-4 centimeters. Now, that's CB squared. So I'm going to have to square root this, square root both sides, so I get CB is equal to approximately 4 centimeters. Okay? There we go. Now, this is very time consuming. We have to do a trig identity, and another trig identity. There's a faster way. The faster way is called the cosine, and that's what we're going to learn today. This page here develops the cosine law for you. I strongly suggest going over this and reviewing this page. So eventually, pause the video, review it. Welcome back. So now, what we want to do is we're going to look at this here and this here. All right? This one, basically what happens here is no matter what the angle is, the side we're trying to figure out, we want to know the opposite angle of the side. So here, opposite angle of the side. Doesn't matter, we're always looking at the opposite angle, and then the other ones for calculating are used there. All right? Let's take a look at this. So here's my first question. The very first question we did before, but now we're going to use the cosine law. And cosine law states we have small b. If we look at this, we have two lines. For cosine law, we need to have a side, angle, side. We have to follow SAS for cosine law. Or, as we'll find out later, side, side, side can be used for cosine law. Right now, we're just focusing on the SAS, side, angle, side. So side, angle, side. So we're looking at b squared is equal to c squared plus a squared minus 2c a cos angle b. Well, let's take a look. We know one side is 6, so that's 6 squared. The other side is 3 plus 3 squared. The only side that matters here is this b squared. The unknown must be opposite of this. That's the only thing that matters. So in this case, I guess it is c. I should put in maybe from the ones there. So which ones do we want to figure out? We are trying to figure out the length of BC. So that is actually A. So we're going to look at A here. Okay? So we have 6 squared, because this is A, this is B, this is C. So we have 6 squared plus 3 squared minus 2, 6 multiplied by 3. And then we have cosine, and angle A is 36 degrees. So we continue that, I'm going to get 36 plus 9 minus 36 cos 36 degrees. Now when I calculate that all out, I am going to end up getting a total of 4 centimeters. This is a squared, so we have to square root this answer. That's going to give me 4 centimeters. All right? Next one. We want to take a look here at q squared. It says complete the following calculation for side q. So what is q equal to? Well, here's side q. Well, q squared is equal to, well, there's p, there's r, p squared plus r squared minus 2, and then we want p, r, and all of this is going to be cosine of angle. Well, we're trying to find q, so we want angle q. All right? So there is our first part. We completed our formula because it's in terms of q. Next part here is we're filling it in. So we know PQ, which is R, side R is 1.7. We know QR is 3.1. That is side P. And we know angle Q is equal to 110 degrees. So now we're going to substitute all of these into our formula. So we know Q squared is equal to P squared. Well, P squared is 3.1. And we have plus 1.7 squared. And minus 2, 3.1 multiplied by 1.7. And that's going to be cosine. I'll just put cosine of 110. So, if we calculate all of this together, I want to get Q is equal to 16.105. Q squared is equal to that. That means Q is equal to 4 centimeters. Okay? Now this last question here, I want to kind of skip because it's worded kind of awkwardly. So if I was to draw this out, it's saying we have A here, and it goes 30 kilometers. Bellevue is 30 kilometers north. And then it's saying Churchville is 18 kilometers northwest. Now they're assuming that this is 45. That's a very hard thing to make. So there is my triangle, and you are to calculate based on that. So they're assuming that's 45. This here is 18. And now we have to find, here we have A, this is the little b, this is the little c. Okay? So if we were to do this, that's the confusing part there, because it's, let me read up the question, because it says it's northwest. So they want it 45 degrees from here to here. So when we do this, we just use our formula again. So what's the side we're trying to figure out? The distance between these two, which is A. So A squared is equal to B squared plus C squared. And we have minus 2 BC, and then we have cos A. Plug in what we know, I'm going to get 18 squared plus 30 squared minus 2 multiplied by 30 multiplied by 18, and we have cos 45. Okay? So when we calculate all this, I am going to put all this into your calculator. We end up getting, which is A squared is equal to that, so we must square root both sides. So then A is equal to 21 kilometers. All right? So now, tomorrow we'll go over this, so don't start the assignment yet, because right now we are going to look at it, the other style of triangle. So we know how to find if we are given two sides and an angle. The angle's in between the two sides. Well, the third way of doing this now is if we are given all three sides, we could find one corresponding angle. Okay? So we could find the opposite of a certain angle. So right here, the first example is just putting the ratio. So cos B is equal to what? Well, this is going to be B squared plus C squared oh, sorry. Well, cos B, the odd one out is the two other angles, the two opposite angles we're always going to put first. So we have c squared plus a squared. Then we subtract the opposite of b, it's the only one different, which is b squared. Okay, we're going to subtract that, and that's going to be all over 2, and then c, a are the ones left over. Okay? This is why it is like that. I'm going to rearrange this top formula here. So we want to get cos A by itself. So first what we do is we're going to add, we want to get cos A by itself. So first thing we're going to plus 2 BC cos A. To both sides. Alright? So then we're left with, if I go up there, a squared plus 2 BC cos A is equal to b squared minus or plus c squared. Well, now what we want to do is we're going to put a squared on that side, so we have 2 so this goes there. Then we divide everything by 2bc. Okay, so that's how they end up making that. It's just isolating for cos A. So that is why the only time we use the angle opposite of the, or the side opposite of the angle we want, is just when we subtract it on that side. It's the only time we use it. Everything else is used twice. They're added and on the bottom. So let's take a look at cos. That's going to be a squared plus b squared, and this is minus c squared, all over 2ab, because we add the ones that aren't opposite to it, and then we divide by the ones not opposite to it. Let's take a look at example 6. Determine the largest angle for triangle ABC if A is equal to 14.7. So we just make the triangle. So we have, I'm going to go A, B, C. So we're saying A is 14.7. So this is A, which is 14.7. B is 8.9. That's B. And C is 12.6. Okay? So we want to figure out the largest angle for this one. So we're going to have to do this cosine. We're going to try and figure out the largest angle. So we're going to have to do everything here should be in proportion. So which one's the largest angle? Well, A is the largest side. Therefore, angle A we could say is the largest. Because this here will be the widest in order to make this the longest side, right? Hopefully that makes sense. When we look at this, we're going to have, so we're looking at A, cos A is equal to c squared plus b squared minus a squared all over 2cb. Okay? So we're going to continue this. Well, we have c squared is c squared, we have 12.6 squared. B squared is 8.9 minus 14.7 squared. And all this is all over 2 multiplied by 12.6 plus, multiplied by 8.9. Alright? So this will give you an answer of, we are going to get cos A is equal to 21.88 all over 224.28. Okay, I'll just clear this up so it's more clear. 1.8, okay? Now, if I want to know what my answer is, well, we have to figure out what A is. So this is way back to SOHCAHTOA. To find the angle, I'm going to have to go A is equal to, well, second cos, this 21.88 all over 224.28. Okay? And this will give you an angle of roughly 84 degrees. So we get an angle of roughly 84 degrees. Okay? All right, last question. So here we're looking, we have once again 3 different sides. Don't know an angle. So as soon as we see 3 different sides, that means we have to use cosine law. Now, what are we trying to figure out? The first ship sails 7 kilometers, okay? And the distance between Q and R is 13 kilometers. Determine the angle between the directions of the 2 ships. So 2 ships sail from point P. So we want to know this angle here. We want to know angle P. So we're going to have to go this way. That's P, this is little p. This is R, this is Q. Fill those in. Now we are going to have to use our cosine. And we're trying to find the angles. We're going to go cosine of P is equal to, and we have, oh, this is my P. We have Q squared plus R squared minus P squared all over 2QR. Continue calculating this. I'm going to end up getting, well, the Q squared is 49 plus R squared is 64. And then we have to subtract 13 squared, which is going to be 169, all over 2 multiplied by 56 is going to give me 112. Okay? So now we have, oh, that's a big P. So now we're looking at P is equal to, and we have to add these together. This is going to give me 100, and, oh, here. This is going to give me a negative. So we put that into our calculator. We're going to get negative 0.5. And that's going to give me a total of 120 degrees. Okay? And that's it. And that's how you solve this. Good luck on your assignment, and I'll see you tomorrow as we work on the assignment together.